All right, so now that we have all the steps of the hypothesis test, we're going to bring them all together in exercise 4, as well as, again, sort of compare and contrast this to our sampling distribution information in section 1 of part 6. So, the title of this exercise is, was there racial bias in jury selection in the South in the 1950s and 60s? And I'm pretty sure that we know the answer to this question before we actually do it, but let's see what we can do with statistics. So the information here is that panels of juries, it's 2:30 in the morning, I can't think. Panels of jurors are theoretically drawn at random from a list of eligible citizens. However, in the 50s and 60s, few African Americans are found on jury panels, so some defendants challenge the verdicts. So here's some of the statistical evidence that was found. We have two pieces of information here. One, 50% of eligible citizens were African American, and two, on an 80-person panel of potential jurors, only 4 were African American. Could this be by chance, given that we would expect 50%? So, if we're going to state our hypotheses here, we have basically only 1% that matters, or percent that's given to us, and that's that 50%. The population value, right? So they're saying in the population, 50% of citizens are African American. However, in an 80-person jury panel, which should be a randomly selected thing, right? We only got out 4 that were African American. So this is typically what we'll see in these questions about hypothesis testing for proportions. We'll have some value that we're testing, and then we will have our evidence, essentially. So this is what we want to know, and this is our evidence. So you guys take a moment and set up the hypotheses, our null and our alternative. Part 6, these are both about P, our real. And this now is not talking about the proportion of citizens that are African American. This is the proportion of people chosen to be on our jury who are African American. So this is one jury pool, but we're saying in general, what was the proportion? And it should be the same as the population proportion, right, if it's a fair jury selection. So we believe the true proportion of citizens chosen to be on the panel who are African American are 50%. And what is it that we're trying to prove? Still about P, still about this 50%. We don't have any keywords here, but hopefully we can infer from the context that we're trying to show that it's less than 50%, right? We're trying to show that there is some racial bias and they're not selecting African Americans at the rate that we're seeing in the population. All right, so if we're going to go ahead and do a hypothesis test in this, we're essentially doing a 6.1 piece, right? So we could think about the actual curve here. Bloop, 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 bloop. We expected to see 50%. However, our P hat here, when we looked at this one jury, was only 5%. So way, way, way off to the side. And remember, when we're talking about our P values or our probabilities, we're thinking about things being more extreme than what we observed or following the direction of our alternative. And in this case, we have a left-tailed test. So we'd be looking at this area. And we can do this one of two ways. We can either jump straight to the formula for the test statistic, or we can move this in steps. In the future, I'm going to use the formula for the test statistic. This time, I'm going to move us in steps as if this were a sampling distribution question. So if this were a sampling distribution question, you'd want to know, well, what did we expect for the mean of P? Well, it should have been the real P, which we're going to pretend that that's true. So we should have seen 50%. And the standard deviation for P hat, well, that's real P, real Q all over N. And again, we're assuming that real P is 50%, so we could find this. All over 80. So square root 0.5 times 0.5, oops, So 0.0559. Now, we would use this because this is our step 1. Step 2 in a hypothesis testing situation is to give out an actual z-score. And that's really what that formula is that you would jump straight to in a hypothesis testing question. But we can also just do this from our knowledge of a z-score. We want to know how far is 5% from 50 if we use those standard deviations as our steps, right? So we can see how far away that is. 0.05 divided, subtract off the 0.5. So we're about 4 or 5 away, but we want to know about this in terms of our standard deviation. And we have a z-score of negative 8.05. Negative makes sense, and I just want to point this out. Anytime you're doing a left-tailed test, you should have a negative z-score because we should be looking at something less than our hypothesized value. And this z-score is crazy unusual, right? Not just unusual, I mean, like, we've never seen anything as big as 8. And in fact, if we go to our table, the table doesn't have anything that low in it. And we go straight to that table. And we can go to our standard normal. The lowest negatives we have here is negative 3.49. So we can't even get something at negative 8. And if we type this in our calculator, if we did a step 3, we could have done a normal CDF, either with the z-score itself or with the actual values. Negative E99 up to 0.05 with the mean and standard deviation we found. Your calculator is going to tell you that this is 0 because it's just so freaking small. And in fact, if you had a calculator with a higher tolerance, you would find out that this probability is crap ton of zeros, 1/4. So basically, this is where the whole hypothesis testing idea comes in. Is if we're looking at this, there's only 2 possibilities, right? Either this was just a really, I mean, this much unusual, right? This much unusual jury. Or maybe our initial assumption, oops, did not mean to grab that. Now I have to figure out how to put it back. This is unfortunate. Sorry, guys. Or this is wrong, right? Our initial assumption was wrong. And that's where step 4 comes in. Since our p-value, this probability, is so freaking small compared to any alpha we would use, we're going to reject that null hypothesis. And we're going to say there is no way they were pulling African Americans at a 50% rate for this jury. They must have been pulling that rate at a less than 50%. So there was racial bias in the jury selection in the South in the 50s and 60s. We're not making a groundbreaking conclusion here, but this is the type of thing that we need to be able to do to prove something like, oh, we need to be recalling this particular item or something like that.